Hey everyone, the last part of today's subjects is learning strategies. Learning strategies are not the same as scaffolds. They are student supports for something that's too difficult for that particular student, but it's actually teaching them an approach to complex tasks in different ways. And these are things that successful learners know how to learn. They're able to pick these up on their own. But because different people approach things in different ways, some students are not able to learn in the same ways. And these things that just come to some students, or maybe they learn them outside of school somehow, some students need explicit instruction. And so some cognitive processes can be taught and that lead to learning. So let me give you an example. There are lots and lots of strategies for reading comprehension. Reading comprehension is so much more advanced now than it was when I was a child. And so when we think about reading comprehension, reading is decoding individual words, but comprehension involves understanding what you're reading. And so successful readers, when they're reading, what's called activate prior knowledge. They think about, it's sort of that constructivism. They think about what they're reading, what other things they know that are related to what they're reading, and then how it relates to that previous knowledge. And so they also perform self-questioning for understanding and check to see what they do and don't understand. And they think a lot about these relationships between new and existing information. So other students don't do that. They might decode the words, but they don't really think deeply about what they're reading. And so reading comprehension strategies with mnemonics teach students to follow steps. And there are reading comprehension strategies for lots of aspects of reading. One of them is called THIEVES. So this, you read the title, headings, and introduction, and that's called previewing. That's supposed to get you a sense of what you're going to read and hopefully bring up prior knowledge. And then you read the first sentence of each section, again to just sort of familiarize yourself with what's happening. And then you look at the visuals and think about the vocabulary. And then after you read it, you read the end of article or end of chapter questions. And then after you're all done, you summarize your thinking. What is it that I was thinking about? What did I get out of this? What's the summary of it in my own words? And what's sort of the analysis behind it? For computer science, we actually created a strategy that borrows some of the ideas from THIEVES. And the purpose is to use this for Scratch programming. And Scratch was introduced in the constructionism slides, but we didn't really show you about how it works. So like THIEVES, we have people read the title and instructions. The instructions tell how to use the program. So these are programming projects, and you can run them from one page. And then we put in a purpose that tells students what they're supposed to learn from this activity. That's something that wouldn't normally be in a Scratch project. It's just for what we put in all of ours that are examples for students to learn from. And then finally, we have students play. They run the project and see what it does. We want them to closely observe what actions they see as a result of what user action. Like if I click on this sprite, what happens? And so Scratch uses all 2D images as the elements. So Scratch programming creates animations. And so it's a bunch of 2D images on the screen, and they're called sprites. And they can react to the keyboard. If I press the letter A, maybe something happens. Or I press the space bar. Or I can click on different parts of the screen, and maybe things will respond to that. Or we can click the green flag, which is a go button, and we can program it so that a set of actions occur from pressing go. So students play on the outside, and then they click a see inside button that puts them onto the code. So they can see the code, and then they can also see the output at the same time when it runs. And so in order to find code in Scratch, it's different from like C#. In C#, we have a main program, or C, or C++, or Java, right? All execution begins with main. But this is event-driven, and so everything responds to events. And so I need to find where's the code for when I click the green flag. Well, it turns out this code is organized by sprite. You can't just find all of the code that runs with green flag. You have to look at each sprite and find the code that goes with it. So that's what the S and E are for, is look, if you're trying to find code, first identify what sprite did something, and then what event caused it to it, and you'll find the code. And then finally, once they've connected the code to actions they see and made guesses about what code might have been doing what, they can try out those guesses by making changes to the instructions. Like maybe you would change a parameter. If you're supposed to move 20 steps, maybe you move 100 steps and see what happens. Oh, it moves farther when I do that. Now I have a better understanding of what the move block does, the move instruction. So this is sort of a roadmap for learning from example code in Scratch. Okay. All right, so let's look at, we've done various things right now. We've learned about active learning, scaffolding, constructionism, and so let's put it all together. And there are two axes that this is showing. One is the role of the teacher, how active is the teacher, and one is the role of the child, how active is the child. So for example, those worksheets would have been the child doing something, but the teacher being passive. Or the child is doing something, and the teacher gave them the worksheet. So that would be teacher active and child active. But if the child is active and the teacher is not active, that's like unsupervised learning, so discovery in free play. If the child is passive and the teacher is passive, that's just growing up, right? That's not explicit learning, but it turns out that children learn just by growing up. And so we have to count that as one of the categories. And so then we have the teacher being active, and then how active is the child. And so we have what's called direct instruction, and that and sometimes that gets a bad rap because people think it's that pouring in the brain where the student is completely passive and the teacher is doing everything. But you can have some element of direct instruction with a lot of active learning put on top of it. So, so anyway, this sort of gives you a way of thinking about the different techniques that we've talked about in the class so far.